you doing?
Great, great. How are you?
Good. Thanks for meeting again. I really appreciate it.
Let me share my screen.
Okay. Can you? Let me make sure. Yeah.
Yes.
Okay.
All right, it's here. Shall we dive in?
Yeah.
Awesome, awesome. All right, so I'm gonna talk a little bit about like how you could craft a dashboard in Python using Streamlit. By crafting, I mean, I guess you could create the app, right? You could build the app, but by crafting, it kind of gives like a tone of like artistry to, like the app creation process. I like to think of, like creating an app, like a Streamlit app. It's kind of like you're creating it in small iterations. You're making improvements like line by line. You could create the app, like the first version of the app, and then maybe like for another 10 hours, do something else, come back to it. Maybe you have some eureka moments, add to it, and then kind of like have the app evolve over time. So therefore, crafting. So when we're creating a dashboard, we're essentially taking a data, like it could be like a raw data, numerical data, and then we're changing the representation of the data. We're making it visual, right? But before doing that, let's have a look at the importance of data. So Hal Varian, Google's chief economist and also UC Berkeley's emeritus professor, mentioned that the ability to take data, to be able to understand it, to process it, to extract value from it, to visualize it, to communicate it, and that's going to be a hugely important skill in the next decades. Um, I've seen like the rise of data science, like in my, um, I mean, collectively, it's like I think almost 20 years working from a field that was not yet called data science. It was like data mining at the time. Machine learning was already there. And then I believe it was like an article published in the Harvard Business Review talking about like data scientists as being like the sexiest job of the 21st century. And that kind of like catapulted the field to like the front lines, and everyone wanted to be a data scientist. Um, and that was like before, like the rise of AI and agentic AI and ChatGPT. But yeah, I mean, data is still important. LMs are relying on data. So it's like the pinnacle of all of these AI enabler.
Yeah.
And yeah, so we could think of, a picture or a data visualization or a chart, a plot as being worth like 1,000 words, right? So a picture is worth 1,000 words. Therefore, like a chart, a data visualization is also very important in that you could condense a lot of information into a chart. And being visual also makes it a little bit more tangible because when you're describing data, like numerical data, you could use words, but then I don't think it's that, tangible as, you seeing it yourself, the trends that has emerged, the correlations, the relationship, and or even like a diagram of a complicated process is very important for understanding the essence of what the researcher or you, the creator or author, are trying to convey. So therefore, diagrams, visualizations, I think they're very important here. And therefore, yeah, so data visualization will allow you to quickly, grasp the essential trends, outliers, and also other insights from a visualization as opposed to a static table. And yeah, I created this hand-drawn illustration on an iPad. I think it was like using a GoodNote app
Mhm.
there. Oh yeah, so this is the data, and then you're taking that tabular data, structured data, and then you're visualizing it. And yeah, it's worth 1,000 words as shown here. And this is an overview of the exploratory data analysis or EDA. So typically when you approach a new data for the first time, what you want to do is you want to quickly eyeball the data, get like a grasp of what the general trends of the data is like. So it's very dynamic, like for me when I was in academia, so I'm currently working in tech as a developer advocate, like, creating content, teaching online, as such. But prior to that, I was a professor at a university in Thailand. And the research that I did was kind of like trying to make sense of biological data sets, and we're
Mhm.
trying to figure out like what properties would make a compound, a molecule, effective at inhibiting a certain enzyme or protein, which will lead to like drug therapeutic effects
Mhm.
of the drug. And yeah, so when you're trying to approach the data for the first time, you want to try to understand the relationships between all of the variables in there. How does it affect the therapeutic activity? And one of the key things that you want to do is, collect the data. And the data could come from different sources. It could come from a research article embedded in a picture table, which we have to extract into a tabular format. It could come from the supplementary information of the article, which is hidden behind like several layers of maybe paywall, or it could also be hosted externally, not in the same platform as the publisher in which the journal was published in. I mean, in which the article was published in, like Elsevier, ACS, American Chemical Society, um, PLOS One, Nature, Science. So data is like very distributed. It's all over the place. So what you need to do there is like collect data, right? There are databases that are helping you in that respect, in that it kind of aggregates all of the data, curates the data, makes it available for researchers, practitioners to have access to. So that's a great thing. However, when you combine all of these data sets, what you want to do next is you want to clean the data, right? And data could, it could be quite messy. It could be having different standards of naming conventions could be different. It might mean the same thing, but then when you combine it, the column names might be different. So you have to kind of like curate the data, clean the data, and then perform some basic analysis like descriptive statistics, maybe visualize the data, looking at trends or patterns that might emerge, apply statistical analysis, tests to investigate any correlations that you might see. Another thing is you could also perform like feature engineering, where you could take two or multiple features and kind of combine it together, or
Mhm.
apply like transformation to it so that you create a new feature there. And then all of this could then be used by machine learning to create a predictive model, in which you could then, make a prediction by providing input, and it will make the prediction of the output that you're interested in. So there's a lot of steps here, and it's just like the gist of like the overall process that you could do with EDA, and then further down along the line could be building a machine learning model, and after that trying to simplify it, share it to others like biologists so that it's more simplified. Maybe you want to make a dashboard or create like a simple interface in which they could make a prediction,
Mhm.
add widgets to it so that they could interact with the widget on their mobile phone. They won't need to install the environment. They don't need to know in Linux. They don't need to know any, programmatic functions or Python or scikit-learn to build the model. All they need to know is just, switch the slider widget and
Mhm.
make a prediction.
In this process, this workflow, are we only talking about tabular data, or all the
Right.
data is eventually going to become tabular data? Is that the idea?
Oh, right. I mean, aside from tabular data, you could also analyze data that is, what do you call it, unstructured,
Right.
like images, audio, um, and those that are just text, right? Like natural language. But then from those, you could still transform it, right? You could transform the unstructured information into like a semi-structured, like a JSON.
Mhm.
And then you could make and then convert that. You could aggregate it, you could add some insights to it, add some different angles to it, and then kind of simplify it into a tabular or structured form.
Okay.
Um, yeah, I'm actually creating a course right now, which is due to be released soon. I can't disclose the exact title of the course, but it's gonna be pretty cool. And yeah, and so the essence there is like taking an unstructured data, converting it into structured data, and then um, performing data analysis on that.
So we want to at least be dealing with structured data. That's the idea for this process.
Oh yeah, I mean for this particular
Yeah.
process.
Okay.
Yeah, so I mean, there are techniques for unstructured data analysis.
Mhm.
Like, let's say if you're analyzing text, right? You could have like the traditional approach would be like, let's say you want to analyze a sequence of DNA to see what the pattern is like if the DNA encodes a particular protein or a sequence of a protein might dictate a particular structure.
Mhm.
So they have this thing like called like I think it's like DNA or DNA logo where you can see like the relative height of the of the nucleotide at that
Mhm.
particular position. If it's like A more at position 109, then the A will be higher, like bigger size.
Mhm.
Or at position 120, it might be uh, T might be higher. And then you get to say like, okay, at the various location um which nucleotide or DNA are particularly higher at specific location, which are the patterns that emerged from analyzing the data. But yeah, I mean that's just one way of doing it.
Okay.
So if you kind of take a bird's eye view of analysis, you're starting with data, right? And then when you have that data, it's like raw data without any context whatsoever. And then you're going from data to information as shown in the diagram here. So you're starting to understand the general colors of each of the points, right? When it's like a raw data, it's like pretty broad, pretty vague. And then you kind of add information to it through analyzing the data. And then when you analyze the data, right, you're trying to see like, okay, maybe some patterns emerge. It might have particular clusters, these particular points are located closer to one another. And then if you apply it and kind of make it into, um, if you take your knowledge that you gained from your data analysis and you apply it to the real world in several instances, then eventually you'll reach wisdom through knowledge from several applications. And then you kind of consolidated that into a wisdom, as shown here. And then at the bird's eye view, you get to see, okay, it's a star. I guess there's a lot of analogy where you could also represent this. It's kind of like there are several blind men in the room, and then they're trying to like figure out what's this animal, right? And then it's an elephant, right? But then like at different parts of the elephant, you won't know what it is actually, and
Mhm.
the characteristics is what is rather different. And so yeah, I mean with data analysis, you're pretty much like in a dark room and trying to figure out what things are, where they are, what does it mean, and as you kind of perform analysis with different method, you kind of get to understand it and gain clarity over time. And so therefore, I think it's an art in itself in that there's no like predefined like best practice of like here's what here's like the de facto way of performing data science or data analytics here. So it's really like very creative. So the researcher will get to decide what approach they want to do, what features they want to use, how they want to perform feature selection, which machine learning model they algorithm they want to use, how do they want to represent their their information, and how do they want to make it in like accessible to the general public or others who are not into machine learning, but so that they're able to leverage machine learning to make an informed, data-driven decision.
Where does this hierarchy come from? Did you develop this hierarchy, or is
No,
this
no,
kind
I
of well
didn't
known?
develop it. Yeah, I drew this image, but the
Right.
DIKW, I think it was like this researcher. I could recall his surname, Akoff.
Yeah.
If you search Google for DIKW hierarchy, I think you'll find him.
Hmm.
Russell, yeah, Russell Ackoff in the late 1980s and 90s. Yeah, so he developed this pyramid of, they
I
call
see.
it BIKW pyramid, the
Okay.
hierarchy where you kind of start from the bottom, the base of the pyramid, and then you work your way up
Hmm.
from data to information, knowledge, wisdom. Eventually, we want to reach wisdom from the raw data.
Hmm.
Mhm. So I guess we could think like research or science as a whole as kind of like generating data. They perform experiments to generate data, And then when they perform the experiment and then they generated the data, they might analyze the data in one approach, in one aspect. The data, if they share it, that would be great. That would advance science.
Mhm.
If they share the data, another team of scientists comes over, takes the data, has a different approach to analyzing the data than the original research team. They have a different angle, right? So I guess you could look at data in different angles and or overview and or aggregate takes data from different silo, merge it together, form a completely new analysis, a new
Mhm.
viewpoint. And I guess that's the way to kind of build this snowball effect for advancement of science.
I see.
Yeah, so dashboards are important in that I believe it helps to simplify data, especially making it uh, more tangible through visualization. So that's the advantage of having a data visualization plot. But then if you make that creation of the data visualization interactive, you make that process self-serve, meaning that you're able to, let's say, look at this dashboard, and then you want to know what factors might be um, causing a particular migration, for example, for the data that you observe from the map chart here. And then if you are able to interact with the dashboard in a self-serve way, you could answer your own hypothesis. And then through this several iteration of analyzing the data through, manipulating the widgets here without even knowing how to code, for
Yeah.
example, will empower you to understand the data more and more. And so how do you actually do this? It's like, building a dashboard that's interactive and with with the age of AI, ChatGPT, you could essentially write a prompt, right? In ChatGPT or Anthropic Claude, and then
Mhm.
ask it to create you a Streamlit app.
Yeah.
Um, and nowadays, I mean, all of these, all of these apps, right, are on GitHub, and of course, they're probably indexed by all of the large language models.
Right.
And over time, like the models are getting better and better. You could now even provide it like a vague prompt, and it'll generate like a reasonable baseline of a Streamlit app for you.
Mhm.
And if you know a little bit of Streamlit, then you're able to tell it specifically what widget do you want at which particular position. How
Yeah.
do you want to read the data in? How do you want to store the data? Tell it the tech stack that you want to actually use,
Right.
and then you're going to get a very powerful Streamlit app. I mean, I would, like back in the days, well, it's only what, a year or 2 years
Yeah.
ago before ChatGPT was here. It's like
Yeah.
you'll spend probably like weeks or months to create and, craft a pretty good Streamlit app. But now, like in a day or two, you could create a very advanced Streamlit app. And yeah, it's like pretty amazing. And yeah, in a nutshell, having a dashboard allows you to share information across the team. You can monitor the data changes in real time, and you could keep your team and also like, other stakeholders aligned based on the data that you have here. Yeah. So overall, like the dashboard design, if I could consolidate this into steps, like in a summary overview, it would be to first define what key metrics you want to measure. And then great to perform an early analysis through an EDA, and then to actually just build the dashboard app and then build and refine, and then deploy the dashboard app. And for this, you have several choices, right? You could deploy it locally, you could self-host the app, you could deploy it on the cloud. There's several options on the cloud, and the easiest and like free approach would be, Streamlit Community Cloud. And of course, there's so many other AWS, Azure,
Mhm.
um, DigitalOcean, and yeah, I mean the list goes on.
Is Streamlit Cloud
Mhm.
free?
Streamlit Cloud, is it great? I mean, I've been using it because it's free.
Yeah.
When I was not part of the Streamlit developers team, DevRel team, when I was in academia, I would just deploy it to Streamlit Cloud because I don't have to configure anything, right?
Yeah.
Let's say when I deploy it as in other framework, I'll have to configure all of the Apache config stuff
Yeah.
and the routing of the IP stuff. But with this, I get the subdomain, right? Something like something.streamlit.app.
Yeah.
And then I just need to host the app over on GitHub and then connect that to the Streamlit Cloud,
Hmm.
then deploy the app. And it's live in maybe 30 seconds. It'll
Yeah.
spin up a new server for you and then it's live. So it's free if you want to deploy public apps. I think they allow you one private app for deployment.
Right.
But I mean, for academia or just hobby stuff, I think Streamlit Cloud is pretty much enough for that. And you don't have to pay anything for that as well. It could get pretty costly.
Yeah. Are you a developer on the Streamlit framework itself? I know you're an advocate and you're doing lots of demos and you're talking about it, but are you like an active developer as well on the framework?
Unfortunately not. Yeah, so I'm just, using
Okay.
it an
Just
early
using it. Okay.
beta tester and kind of,
Yeah.
creating tutorials
Yep.
on it. Yeah. But also I was part of the early DevRel team when
Yeah.
Streamlit was a startup.
Oh, right.
Yeah, I mean, if you take a bird's eye view, these are the um, an overview of Streamlit. Here you have like basic code here, and then you create your app. I believe like the syntax is pretty readable, and
Hmm.
then you're able to figure out what each lines are doing. Like import, I mean the typical Python syntax here, importing the Streamlit framework, importing pandas, write something out in the string, and then you want to read it from a CSV data into a data frame, and then you want to create a line chart. So it's pretty straightforward, I believe. And there are like hundreds of widgets that you could potentially use, like upload a file, pick a number by
Hmm.
sliding a widget. You can make the widget like two-ended, like a data range. You could have a calendar widget. You could have a color picker, and yeah, several more. So, I mean, let's just maybe breeze through all of this. So I believe like a lot of you already, let's say if you already know Python, I guess you could also use Streamlit out of the box, just kind of fiddle with it. And then I think you will be able to create something reasonable in your first few minutes of using Streamlit. So the powerful thing here is that I believe it's pretty straightforward. You have a script and then you can make an app, and it's fairly simple. And yeah, so there's a lot of things that are happening under the hood. But then like what the developer are seeing is just, low code that
Right.
they'll just need to know and create. So basic prerequisite here for using Streamlit is have a basic Python knowledge. If you don't, you use ChatGPT and it will help you. If you encounter problems,
Mhm.
copy the error message, paste it into ChatGPT. It helps you, provide like some potential advice on how you could fix it. But then for those who are already Python developers, I guess they could just, copy paste whatever they have from their existing code base and create something out of this. Yeah, so obviously first part is to install Streamlit. You could do pip install Streamlit. You could say Streamlit hello to test whether your installation is successful. If you want, if you have like a Python version dependency management like Conda, I think this is also pretty good. Like create a dedicated environment for your app or project so that it doesn't ruin your current tech stack of libraries that you have. And then from this dedicated environment, create like a new installation dependency using Conda, as shown here.
What is your development environment? Are you doing this locally on your machine or are you working in the
Mhm.
cloud?
Good question. I do it locally and also on Community Cloud. I haven't yet tried to deploy it to Azure or AWS or DigitalOcean.
Yeah.
There are tutorials available online, but then like you have to do a lot of configuration.
Yeah.
Maybe someday I'll try it and maybe write a tutorial on how to do the configuration. But for now, yeah, I just mainly deploy it to Streamlit Community Cloud
Hmm.
and and also fiddling with the Snowflake environment. And I'm actually creating a tutorial, like a picture tutorial. I plan to upload it to Twitter and LinkedIn on how to, create a Streamlit app and also connect to a database on Snowflake, but then the app will be, public
Yeah.
on Streamlit Community Cloud. So yeah, that's some of the things I'm working on.
But the development itself, you're doing locally on your machine.
Actually both. So
Oh,
I'll do it locally and then maybe like if I need to do some minor adjustment, I'll just, edit it directly from GitHub. Maybe if I'm on the go, like I could do
Oh,
that.
I see. I see.
Pretty flexible.
Yeah.
Yeah. You could work locally. Maybe if you have your phone, maybe you are on the train,
Yeah.
you could make some adjustment to it and it's instantaneous. So yeah, I mean, it works with all of the Python, libraries, and
Mhm.
you could go to streamlit.io/gallery. I think they have like long lists of categories for you to explore. And I guess let's save this for later. And I guess we want to get to the building of the dashboard itself. So recently I created this dashboard app, and then I created a kit, meaning that you could just clone the repo and then you could deploy it, and then in like less than a minute, you'll have this dashboard up and running. So I created this hypothetical YouTube analytics data, and I have the Jupyter notebook available in the GitHub repo,
Mhm.
which I'll show you in a few moments. So the data is programmatically generated through like several chats discussion with Anthropic Claude or ChatGPT.
I see.
And then with that code, I kind of prompted to like generate like a realistic YouTube data and then try to have like seasonal effects and have the channel grow organically, and let's see how does that affect um the actual one here. And then yeah, if you want to have a look at the app, it's here. So let me see if I could.
Yeah. Let me bring that up.
Right.
Dashboard slash kit.
Yep. Dash
I
kit.
got it.
Yep. So I actually created this Streamlit app, with the help of Anthropic Claude.
Mhm.
So the data is generated through Claude. And then I tell it explicitly, like I want like, like the basic widgets to have here in the sidebar. But then I have to still manually add, like the container border color here, add the chart here, use st.metric to add the numbers here, and then, explicitly kind of plug in certain variables into the metrics here.
Yeah.
And then, kind of like fine tune it, add, the visual aesthetic part of the Streamlit dashboard. But, ChatGPT, Anthropic Claude kind of gives you a reasonable head start, like maybe
Yeah.
50% of the initial code that you're used, but then the refinement process is, it's practically you to make it
Yeah.
look better. But yeah, so this is the dashboard,
And
like
then
yeah,
where's the data sitting?
right. So that initial version was actually in here,
Okay.
right here
I see.
in the repo. And as I mentioned already, I've just created like a simple tutorial, which I'll show, like how you could upload this into a Snowflake environment
Mhm.
and then kind of call it from there. Yeah, so this is a template repo here, and then I mean, let's see what account am I on? Okay, so let's say I want to use this. Okay, I want to create a new repository. Okay, so I'll give it a new name, like maybe dashboard, or how about my dashboard, and then just okay, leave it as public, create repository. All right, so the repository is in here, and I'll go to, so I just closed this one. This is already deployed. I'll go to Streamlit Cloud. I'll click on Create App. I'll click on Deploy a Public App
Mhm.
from GitHub.
I see.
And the repo is called My Dashboard. So therefore, I just type in the initial words,
Mhm.
dashboard, and then it'll, give you the branch where it is in right now. So it's in the master branch. So that one is correct. The file is streamlitapp.py, which is this one, and it's correct. So let's say if you name it something else, then you want to just double check that the name of the file path is the same. Um, it gives you the app URL, which is like automatically generated from the GitHub repo name. You could change it totally to something else. And like you could say, okay, my dashboard like that without the dash. Oh, someone has already taken that. Um, Data Professor dashboard. Okay, it's free. Oh no.
Eh,
Dashboard number one. Well, I mean they're pretty generic.
yeah, there's at least 5 dashboards.
Right. Okay, dashboard kit number two. All right. We already have number one. This is number two.
Hmm.
And then click on deploy. And then the app is, a new server has been spawned for this particular app. You could click here on manage app and then you'll see kind of like the command line of it booting up.
So all you did was create a new repo from a
Mhm.
template,
Right.
and you're just deploying what's in that repo to an app.
Exactly. And then you could make modifications to the code here
Right.
and then it will be reflected online. So this server is, created from scratch and it's installing
Yeah.
all of the prerequisites that you have. And so in the repo here, in the requirements.txt,
Mhm.
we're essentially just using Streamlit and pandas.
Yeah.
And the chart that you're seeing is like built in, and under the hood is using Altair.
Okay.
So we're using the bar chart and the area chart, and under the hood is using Altair for that.
Can you just describe what that is, Altair?
Altair is a library that visualizes data, similar to Plotly. It's very interactive,
Yeah.
and yeah, I mean the generated chart is like vector, meaning that it's not raster,
Hmm.
and it won't break if you zoom in, like 500%. It'll still be sharp. And yeah, I like it in that it's very clean.
Yeah.
And it might not be as powerful as Plotly, but then for the most charts that I'm creating, I mean it's available there, so I think it's sufficient for my use case.
So back to the app.
Yeah.
You deployed it from the repo.
Mhm.
You don't have to redeploy if you make changes to the code base.
No, so I just make the change and
Yeah.
it'll instantly update the app.
That's cool.
Mhm. Okay, so it's already deployed. So dashboard kit 2, and this is already here. Change it to area chart, make it weekly, make it monthly, make it quarterly, and then like the chart will update in real time. You could essentially change the time frame from September to October 1st, and let's say change it to October. Oh no, okay, it's up to the end of September. Let's say change it to August, end of the month, and it'll update the chart in real time. So it's actually what is happening here is the widget here will act as kind of like a filter, and
Hmm.
it will filter the data frame, the pandas data frame, and once
Okay.
the pandas data frame is updated, the updated data frame will then be read by the code that is generating the chart.
Right.
So it's very instantaneous. So you modify it, you see the updated chart in practically real time.
So
Maybe
these visualizations, these charts are pulling from a filtered version of the data.
exactly. So we could have a look at that in the code here. So you see that I have several versions in here, but
Hmm.
the version that is deployed is the Streamlit app. So
Hmm.
these are like the early versions. Streamlit app. So it's all of the lines of code here is 170 lines of code. Um,
Not that much.
Not that much. It could be less,
Yeah.
but then, I guess we're trying to make it readable. So we're just using Streamlit Pandas and the datetime for
Mhm.
the format of the datetime format here. Um, Here's like the page config, the page title that you see at the top here, YouTube channel dashboard. You could add the icon as well, and it will change from the Streamlit icon to a emoji
Mhm.
of your choice. And I believe it also supports materials icon now as well. So, and therefore your choice of, icons are expanded several folds. Here, just created some helper functions that we're using in the dashboard.
what is the what's that annotation above the function?
Oh, right. Yeah. So without this, it'll load the data like, typically, normally it'll load the data. So if the app loads for the first time, it will start the loading.
Oh,
It,
right,
it might take the it might take some time, right?
right.
And if it loads for the second time, it'll reload. It'll start over and load the data. But then with the catch data decorator here, if you load the data for the second time, and if the data is the same, it doesn't
Yeah,
change,
I
then it
see.
will call from the cached version. Therefore, your app will run slightly faster. And you'll see the effect if your data is very large. But since our CSV data is pretty small
Yeah.
here, even if you don't have this catching decorator, it probably wouldn't, it wouldn't make your app so slow. But then having it will make it faster in that it doesn't have to start over again. It doesn't have to, reread the data and then display the data, perform the operation that you have in here. So it saves you some milliseconds for a small data.
Do you have to worry about the size of that? So let's say the data was huge. Let's say that
Mhm.
CSV file was, I don't know, a gig.
Right. Hmm.
You have to, and you have the cache data decorator. Do you have to worry about the size of that? Can you configure that, or do you not?
Oh,
Is it
um,
abstracted? You don't really need to worry
yeah,
about
it's abstract. You don't have to configure it.
it. Okay.
But if you want to configure it, I think they have options for you. Like if you want to store the cache locally, you
Oh,
can
I see.
do that as well.
Okay.
Uh-huh. So it doesn't, you won't see the effect if your app has like a minimal data set.
Hmm.
But last year, or actually almost 2 years ago, when ChatGPT first came into the scene, and then there were like several LM models, I mean, libraries being introduced. I created this app called the state of LLM
Yeah.
dot streamlit dot app with dash state dash of dash LLM dot streamlit dot app. And within the first 5 hours, the app crashed.
Ah,
So many people were using it and they were using it at the same time.
yeah.
And the data, because the app is what you call it, data heavy, meaning that it has so many data frames and it has so many interactive charts,
Yeah.
it crashes.
Yeah.
So the thing is, how do I make it not crash and optimize the performance? And there you go. That's only one way. And there are
Wow.
several tricks that I've discovered along the way. Like let's say if I have a data frame of let's say 500 columns, I
Yeah.
don't want to load everything up into memory. What I
Right.
want to do is I'll only load in the specific columns that the data visualization part
Yeah.
chart using, and that will save me a lot of memory there.
I see.
Yeah.
But you had to do that manually, like you had to manually query those columns, or is that sort of built into the framework? It'll pull the columns that it needs for the visualization.
Right, that's a good question. Yeah, so it was manually.
Oh,
So I
okay.
have to figure out like for each chart, I have to optimize it manually. But that's like the optimization
Yeah. Okay.
process there. Hmm. And now they have like I guess they have like what do you call it, Python profilers where you could just see which are the bottlenecks in your code and then you
Yeah.
could optimize that as well.
That's cool. Okay.
Right.
So what are these other functions doing?
Yep. So these are, generating data for the filtering that you're seeing here, like the quarterly, daily, weekly, monthly, and is essentially, putting it into the proper what do you call it? Proper datetime format for
Mm-hmm.
you. And in this function, aggregate data, it will group the data
Hmm.
because what you see here, if you look at the data CSV, if you look at the data, each row will be a day.
Okay.
Each row will be a
I
day.
see.
So depending on whether you're using a daily, weekly, monthly, or quarterly, it will aggregate the data based on the date. So if
Hmm.
you do a weekly, so it'll be like 7 days aggregated into week one, and then the next 7 days aggregate into week two. Group by, it'll group by. Yep. So that's the aggregate data part,
Okay.
and it will create a new data frame for you. And then that updated data frame will then be used to create the chart. And then the aggregate data here is like a base function, which will be called by the weekly data, monthly data, quarterly data,
I
and
see.
we'll just change the whether it's a quarterly, monthly, or a daily.
I
And
see.
if it's weekly, we'll tell it to start the week with Monday.
Okay.
And then we have the create metric chart. So we're making it pretty modular, like each of the function that we're having here, they're
Mm,
modular. And then when you want to change the code, update it,
right.
it'll be much quicker, easier for you. So yeah, we have the option to create a bar chart or an area chart right here. Area chart, bar chart.
Mm,
Yeah, I think bar chart looks pretty cool here. Area chart. Yeah. I mean, you could add more scatter plot. I mean, there's so many things that you could do here as well.
so when you change that chart type,
Mhm.
it's passing the chart type to all those different functions that generate
Exactly.
specific charts.
Right. So if we have a look at the code for the chart generation, somewhere down here, let's see where it is. Metrics, custom quarter, data display, display metric. Oh, okay, right here. Chart selection. Okay, so these are
Oh, I see.
variables. These are variables. So it's like the start date, end date are created into a variable from the widgets here.
Mhm.
So therefore, chart selection will equal to bar if you select it as bar.
Right.
And then in your code of creation of the charts, it will just pull in bar from that variable. Yeah. And then you're applying the
Yep.
variable from your widget into here,
Yep.
and it will be here.
Okay.
Yep. So I think yeah, it's the ST metric chart that yeah, create metric chart here. That will, it will feed in the data frame, feed in the column, feed in the color, chart type, and then it gives like a baseline height of 150.
Mhm.
Yeah, so everything is dynamically generated as you kind of, explore the data,
Mhm.
self-serve. So let's say if you're working, you could actually make this one step further. You could generate a PDF out of this, create like a report
Mm,
for those working, so that let's say that like in academia, it's very often that when you're when you're applying for a research grant and then you're gonna submit a report for the fiscal year, and if you create a code for this, you no longer have to create the chart or the data manually. You could just,
right.
automate that process. Click on the button and it generates the chart for you in real time. And then you could free up your time significantly, especially if you have like several grants where you have to report.
Yeah.
So you automate all of this process.
So, can you show me an example of making a change to the code in the
Mhm.
repository and then seeing the deployment of that in real time?
Right. Let's see.
Something
What do
simple. Could be simple.
okay. Let's say okay, all time. Okay, let's change the name. YouTube channel
Yeah.
dashboard. Okay. You could do this on the phone as well. We just delete YouTube channel.
Okay.
Yes, we need to refresh. Hmm. Page. Oh, okay. Right here. Page title. Sorry. So the page title changed right here.
Oh, yeah. I see. Do you have
Yes.
to refresh or does it automatically?
I think it should automatically update.
Yep.
But I didn't. I thought I was modifying the other part. Okay, let's do this one.
Mhm.
Let's try to go back here very quick.
Oh,
Okay,
I see.
it's
So it
automatic.
listens for that commit.
Yes. And
Yeah.
then you'll be able to see all of the things that are happening here. So it detected that there
Yeah.
was a change and then it updated the app. And then you get to see it's yeah, 17:53:25 on the time of the server.
Yeah.
Maybe
That is
somewhere
cool.
in Europe, is it? Yeah.
So let's say I deployed this and I wanted to add, I don't know, a chart type.
Hmm.
The best approach would be to add a new function, a new chart function to my code, and then I would start there. And then I could add that new chart to the dashboard.
Yeah, so you could easily add another line
Yeah.
like chart type equals to something else and then
Right.
sc dot and then the name of that chart.
Yep.
And then essentially the functions here are the same, and
Yeah.
then you're able to add that additional chart type. So you want to also modify the widget uh here as well. Select chart
Yeah.
type, and add another option here, your third option, and then you want to add like the condition if and then that third option.
And then what if you can go back to the app?
Mhm.
what if I wanted to add another data point? Meaning like, okay, I see total subscribers, total views, total hours, total like something else. A
Mhm.
fifth chart.
Ah, a fifth chart. Okay,
Yeah,
okay.
something like
So
that.
we have subscribers, views, watch hours, likes. Maybe you want to do some maybe subscriber to watch hour
Yeah, just some.
ratio. Um, let's see. Let's go back here. So we already have this baseline, display of the
Right.
metric. So you could just go over here to the columns. So we
Oh,
generated,
I see.
okay, we generated the columns
Yeah.
programmatically. So before it was like st.columns for, and then you'll have like codes will be like, it'll be, you could call it like codes and then bracket 0, bracket
Yeah.
1, bracket 2, bracket 3, and then you have like individual columns. So for each of this, it would do it programmatically and that it will display the metric for the columns and all of the parameters that you
Mhm.
have here. And then what you need to do is practically just add another line before the closing statement
Right.
here. So you have maybe something, your new metric, and then you specify a color that you like,
Mm-hmm.
and then the metrics here will be pulled directly from here, but
Mm-hmm.
also make sure that your data frame also has the particular new column data that it will pull from,
Right.
and then it will then generate another column for you. And depending on the number of column, is it too condensed for that? Then you'll actually modify the code that okay, let's have no more than 4 columns, and if there's a fifth column, it will automatically go to the next line.
I
But
see.
I mean, this, or you could just collapse this and it'll expand to the full width here.
And of course, if I see this is impressive, and I want to use this, but for a completely different data set. I could
Yeah.
still deploy this as a basic
hmm
framework, and then
hmm
I'm just going to start editing my code
Right. You just
so
change
that
this line.
yeah, so that I can load
Yep.
new data, but then also make
Yep.
adjustments to the charts and things like that based on
Exactly.
data points. Okay.
Exactly. Right. But also make sure that you have data already in the CSV file that you upload, and then you
Yeah.
change the name accordingly. So you'll probably
Mhm.
change the net subscriber gain, to
Right.
the column names of your data.
Hmm.
And then here as well, updating here as well. Yep. And I guess you then will have a new dashboard.
What about connecting to a database? Does Streamlit
Yeah.
support that, or am I going to use something in Python natively to
Yeah,
connect to a database, pull in data, and then I can basically use the dashboard with that?
yeah, definitely. Let's see. I think I have an example here. Nope, not this one. This is my work account. Uh, Here in SC Snowflake, I think it's
Okay.
public right now.
Mhm.
So to connect to a database, yeah, I'm actually creating a tutorial as I mentioned early on.
Mhm.
So you have here, you want to have this one as the minimum, and then you
Mhm.
want to have this one as the minimum library to install. I had the other one because I'm using other functions, but
Yeah.
to access the data, you just need this line and this line. And if you want to use pandas, add pandas. You want to make some chart, add the charting library.
Right.
And then very simple, just go to streamlit app.py. Instead of saying dfpd.readcsv, it'll
Right.
be like st.connection snowflake.
Got it.
And then you could start querying your data.
That's it.
Let me show you the,
One line of code.
yes, one line of code. I try to
You still end
simplify
up
it
with
as
a data
much as
frame.
possible. Yes. Okay, so the app is sleeping. Yeah, so just one line of code here and
Yeah.
nothing to import on the Streamlit on the Snowflake side
Hmm.
because all of the heavy lifting is in here, st.connection.
Yeah.
And here by specifying that it is Snowflake. So the
Yeah.
type, so this is the type. The type is Snowflake. If you want to gain understanding of the function,
Okay.
copy this, paste it here, and then go to Streamlit docs, and then it tells you
I
what
see.
it means. So type is equal to Snowflake right here.
I see.
So it will initialize a connection with the Streamlit,
Yeah.
the Snowflake connection. And next thing is you
What
have to.
is what is Snowpark?
Snowpark is a library where you could run like all of the data frame operations and also like machine learning model building. It has all of the functions similar to what you do with scikit-learn, but then
Okay.
created for the Snowflake platform. And there are, like machine learning algorithms in Snowpark as well.
Interesting. And then I
Yep.
saw the sequels in there as well as a type.
Yes. hmm And this is the data loaded directly from Snowflake in a
Oh, I
public.
I don't think I saw any credentials in there or anything like that.
Good question. So I can't show you the exact credential of this deployed app, but
Right.
then
But
let me
there's somewhere in
show
the app.
you. Yes.
Okay.
So for this app, it doesn't have credentials, but
Okay.
let me show you what it looks like. So here, secrets, then you add your credentials here. Um,
Yep.
the exact
Oh, it's a
credential,
secret. Okay.
yeah. So they call it the
That makes sense. Yeah.
secrets management. So it's 3 steps. So it's here. First step is create a requirement.txt, add the library names that you're going to use, create the st.connection, save it to a df variable for the data frame,
Hmm.
and then in the secrets management of your deployed app,
Hmm.
add this credential in here. So you're essentially just going to go here, right?
Yeah.
Go to secrets and then paste here. And then replace this with your account identifier, which will come from your Snowflake account. And then change the parameter here, username, password. So these information are not accessible by the user.
Right.
So it's safely stored there. Yep.
Stored in the
That's all.
environment. Yeah.
hmm
Okay. This is cool.
And I guess, yeah, I mean that's like pretty um
Great.
minimal.
So this is hosted in Streamlit. This is public.
Mhm.
And then I mean, this is all you would really need, but if I did have a domain
Public.
that I had purchased, I could assign it to this app.
Great question. So if you have a domain, what you could do is you could have that domain and then you could have it redirected to this one, and then you
Yeah.
could mask your URL,
Yeah.
meaning that when the user clicks to your domain, it won't see the Streamlit app domain.
Right.
But then if you want to have it like, like a I'm not sure, like you want to have like, the slash and then uh, the parameters that follow, then you have to self-deploy your app.
Okay.
Self-deploying, there's several approaches mentioned here in the documentation.
Mhm.
Deploy, like here, you have Community Cloud, you have
Mhm.
Snowflake, and there are other platforms. You could have it
Right.
containerized,
Yeah.
could have it on Kubernetes. You could deploy it to several places actually.
Oh, Heroku. Okay.
Yeah, and I think there are more tutorials like AWS and
Yeah.
Azure and yeah, so many more. Yep,
Great.
and yeah. Mhm.
This was excellent. I learned a lot.
Awesome, awesome. Yeah,
Yeah.
it was a pleasure.
Yeah. Thank you. So have a good rest of the day. Good
Mhm.
weekend.
Yeah, you too. Take care. Bye.